In many instances of our course, we'll need to conduct matrix multiplication with NumPy arrays. Let's make sure we understand it before making use of it in the real world. If you've taken any intro to linear algebra course, then you've most likely dealt with matrix multiplication, as it's a very handy operation. And we're going to use it quite often in the neural networks section, so I'll cover it very briefly. Suppose we had a matrix A and a matrix B. Then the product of matrices A and B is defined only if the number of columns in matrix A equals the number of rows in matrix B, which is exactly the case, since matrix A has 3 columns and matrix B has 3 rows. And so, given that the condition is satisfied, the way this would occur is you multiply the numbers in the first row of matrix A with the numbers in the first column of matrix B. 0 times 3, 3 times 3, and 5 times 4, giving you 0, 9, and 20. Take their combination to obtain 29. We do the same thing but now for the second column of matrix B, to obtain 0, -6, and -10, resulting in a value of -16 when taking our sum. Alright, now we're done with the first row. We do the same exact thing for the second row. But now restart at the first column of matrix B, 5 times 3 plus 5 times 3 plus 2 times 4, which equals 38. And now the second column, 5 times 4 plus 5 times -2 plus 2 times -2, which ends up equaling 6. And that is all. We've taken the product of 2 matrices, and let's do this in our code really quickly. First, we start by importing NumPy as NP, and then on a subsequent cell, we'll be defining a matrix. And defining a matrix is very similar to defining an array, where we set mat A for matrix A will equal NumPy.matrix, which will contain the same values of the matrix that we talked about earlier. 0, 3, 5, 5, 5, and 2. But we're going to reshape it to be a 2 by 3. Reshape 2 by 3, like what we had earlier. Outputting this matrix, matrix A. Alright. And now on a different cell, we'll define another matrix, matrix B, which we're going to set equal to NumPy.matrix. Again, the same values as before, 3, 4, 3, -2, 4, and -2. But this will be reshaped to have 3 rows and 2 columns. Reshape 3 and 2. And outputting this, matrix B, we get the following, just what we expect. And now multiplying matrix A times matrix B, conducting matrix multiplication, we obtain the result that we expected. The same output can be obtained by setting product is equal to mat_mul, taking the matrix product of both matrix A and matrix B. And I forgot NumPy.matmul. Alright, and now simply outputting the value, we get the exact same result. Alternatively, we can perform the same operation on arrays by making both of these arrays NumPy.array, NumPy.array, and rerunning all the cells, we get the same result. There are many ways to perform this operation. Another option for arrays is to specify matrix A at matrix B. Once again, outputting the same results. That is it for matrix multiplication and how it can be emulated in NumPy. This is a very handy operation, and we'll make use of it in many parts of the course.